Hi learners, welcome to St. Joseph's College. This is BHARATHI from Department of Computer Science. Today we are going to learn a concept from operating system which talks about a process state diagram. I hope this class will be most useful to learners who are the beginners of studying of operating system. Come on, let's dive into the concept of process state diagram. So let me break this topic process state into in its individual units. What is a process? So process is nothing but a program which is in execution, which is being executed. I'll go with a real-time example so that you can better and have a better understanding. If you take sleeping is a process, eating is a process, learning is a process, walking is a process. Each and everything that we do, right, it is a process. So what is there inside a process? So process inside, we will say a set of instruction will be there. Say example, if I want to walk, means what I have to do? I have to stand up, I have to walk, and I have to go. If in terms of systems, I will give an example. If I have to work on a laptop, I have to prepare a document. That is a process. So I have to sit in a place where I have a system or I have a mobile. In that one, I have to prepare the document of which type, and the content should be loaded there, and it should be done in a sequence. So to make that process happen, there is a programming behind the screen, and that we call it as an instruction which has to be executed. So a process is a program in execution that is being executed. So that particular process is not having one single state, where it has many one or more number of states will be there to make that execution complete. So we have process, right, and inside we have a program that is many number of instructions will be there, and that will be having one or more states will be there. And if you take that state, what is a state? State means at present current what does that activity is being doing. Okay, what that is process is being doing. The current activity of the process, we call it as a state of a process. Right. So now I move to a real-time example to make you understand the concept of process. Say example, I want to wake up early in the morning and I have to get into the work or a college. So what I am going to do, how my process is being transiting from one state to another state, that is what I am going to learn out of it now. So see here I have given you an example. Here, new state. I am getting up early in the morning. An alarm is ringing. Okay, I have to get up, bath, everything will be going on in my mind. So what I'll do, I prepare all my dress. My dress will be packed, system will be packed, everything will be packed, kept ready to be done. Now I'll be running state. What? I'll take a bath, pack everything. I'm just in a running state of executing all the instructions. Running state. Then next what I'll do, I want to take my breakfast. But when I want to take my breakfast, my mother will be cooking. So I have to wait over here until I get my breakfast. After my mother gives me, I just eat. I'll just getting back to the running state of putting my shoes, taking my bag and walking around. Now I just go to the last state, that is terminated state. I reach my office. So when I reach my office, the whole process of waking up in the morning and getting into my work, this process is being complete now, right? So these are said to be the 5 states when a process is being started and terminated. So how many states are there? So in a process state, in a process, it come across 5 different process state. New, ready, running, waiting or blocked, or terminated state. So new state means the process is being created. Okay, I have to wake up, get up in the morning. It is being created in the mind. Ready means what? Now I have to prepare to run. Please understand, this is process is ready to run. I am just getting prepared myself. All my things are ready, my bags are ready, my laptops, all my belongings which are needed to go to work, everything is kept ready here. Now I have to make all these things into a running state. I have to execute this process. So that all the things, here what all I have been listed, 1, 2, 3 I have listed, right? So everything has to come into running state. The process is being executed. Next. The process is waiting for some event to occur. It will be in wait state. Terminated means the process has finished the execution. Now we will see each and every state with an example, and also how this transit between the states with a diagram. Right. So the new, ready, running, waiting and terminated. These are the 5 states of a process state diagram. First what will happen? The new state will be there. Here inside we have having a very all the thing process will be stored in our memory. As we have, right, in our memory we have so many things will be there. But at that moment, what I have to do? Wake up. I have to wake up here. So that will be what happens. It will be admitted into the ready state. That will happen in the first state. Next, what will happen? In ready state, it will be taken to running state. So what is there in the ready state? I have told you, right? I have packed my dress, and I have taken my bags, everything kept ready, my dress kept ready, everything is kept ready. It has to be executed now. Now it will be dispatched to the running state to make it happen. Now what happens? If any interrupts come in between, the running state will be taken back to the ready state. This interrupt we will be studying in detail in the next upcoming slide. Then what happens if the interrupt occurs? It comes back to ready state. Then what happens if I am running, right? There was an input output is being needed. I need my breakfast from my mother. What I have to do? I'll be put in the waiting state. Okay, my mother gave me breakfast. What I'll be doing? IO or event completion is being done. Again, I'll be put in the ready state, start my work again, and I'll start to run. Again, whenever the CPU is being allocated with its space, it will be taken back here. Now you may ask me, ma'am, where comes here CPU? We don't understand. Very good. Here we have three important terms called CPU, main memory, and secondary memory. These are the memory places where the data or the process will be residing. It will be taken from either the secondary memory, because CPU is said to be very small in terms of memory size. Main memory we call it as a primary memory, that is the RAM we will say, and secondary memory with the external disk, hard drives, all those things we call secondary memory. As the size means it's said to be very small when compared to CPU has very smaller size compared to main memory. Main memory has a smaller size when compared to secondary memory. Clear? So all the programs will be there in the secondary memory. It will be taken to main memory to do its execution, and if it wants to execute, it will be loaded from main memory to CPU. So this is the process. So where the program will be run? So whenever it wants to execute an instruction, it will be coming into the CPU. Clear? Yes. Now after completing the instruction, what will happen? It will terminate. So this is how we have to understand with terms of diagrams. Now I'll tell you what is mean by interrupt here. So interrupt means what? Some kind of block which happens when we do some process, right? So interrupt in an operating system which helps to manage the transition between process state. First case. These are the four different cases where the interrupt can be managed in such a way. Whenever in running state an interrupt happens, what is the meaning? Interrupt. I give you a better lifetime example. You are having your breakfast, right? Suddenly your father comes over there. What your what your mother will do? Your mother will either take care of you or a father. You understand? So if some person is more priority because he wants to go to job earlier, right? So your father wants to go to job earlier. So this is you, okay? This is you. If here your mother is cooking the breakfast, as your father wants to go to office earlier, your mother will ask you to wait, serve some food, and then the process will be happening, right? So an interrupt comes. Why? Because a high priority jobs comes there. Understand? There is a high priority jobs comes there, so your process will be kept over there, and you'll be again putting back to ready state. The memory will be taken by the father to do his process. You understand? Clear? So this particular process will be paused, and the memory space will be allocated to father, because he is a high priority job which has to be done at that moment. He will be taking the memory and the processing will be happened. Am I clear now? Right? Then what happen? If sometimes if you want to wait for the next food to come, what you will do? You will wait here. So the moving process from running to waiting state, and that is the second case. And what happens next one? Moving process from waiting to ready state. As I received my food, now again I execute the instructions. Then we can resume the process whenever memory is being freed, because your father had his breakfast and he went. Now the process is free. Now you can come and take that memory. You can start doing their execution. You can process. So after completing your breakfast, what you can do? You can start doing the other work, and after reaching the office, your process will be terminated. Am I clear? So this is what we call interrupt, which happens over here. Next. So next I just explain you the 5 states along with the example connection with the memory so that we can have a better understanding. So in a new state, what happened? The process has not yet created, but it is about to create. I am sleeping in the bed, I am saying I want to get up, I want to get up. Yes, it is about to create. Then what happens here? Where it resides now? It resides in the secondary memory. As I told you, please remember this memory diagram. CPU, main memory, secondary memory. Secondary memory means all your external drives, we call it as hard drives, HDD, everything we call it as the secondary memory. Main memory is nothing but your RAM, that's a primary memory. CPU, which is there the instructions will be executed inside a machine. So in the case of new state, the things will be residing there in the secondary memory. So operating system, what it does is it selects the program from the secondary memory and it name it as a process. What is a process? You have to wake up and you have to go to college. So that process is being created and now it is being switched to the ready state. So whenever a process is being switched to the ready state from the secondary memory, right, that we call it as a long-term scheduler. This long schedulers we will study in a separate class. Now I will be telling you about only the states of things. Next one we move to ready state. So what is ready state? I have told you. I have packed my things, packed my bags, everything is set ready to make that going to college or going to work has to be done. So in this state the process has been loaded into the main memory. So here I have CPU, here I have main memory, here I have the secondary memory. So in this state the process has been loaded into the main memory. Here I have a list of jobs, right? That will be loaded into this main memory to make it happen. The process is waiting. So what is here been doing? I need to have bathroom. I need to go to bathroom to take my bath. I need to go to my room to dress myself. I need to go to my study area to pack, to take everything from there. So the process is waiting for the execution on the CPU. So everything is set ready, but I need the CPU to do the processing, to do the execution. So the operating system maintains a ready queue for all the processes which are there in the ready state. So in my ready queue, which all things will be there? Packing up, my food, my things would all be ready state will be kept over there. So this will be done. So all the processes which are ready to execute on the CPU but are waiting for their turn. Okay, I am ready. If the turn comes, I will be executing this space. That is what about the ready state. Clear? Here I have a better example, right? You can understand. My packing is ready. My dress is ready. My laptop and all my books are ready. Okay, everything is kept ready. But when it comes to execution, I have to go to bathroom to take bath. After bathing only I can do my dressing. Am I clear? Then after packing, after dressing, I can take my laptop and books and I can go to office. That is the sequence. So this is how everything is ready. But what happens here, which has to be done first, will be designated by the schedulers. Now we move to next state that is called a running state. Running state means what? Whatever I have told over there in the before slide, which has to be executed. This is the main phase of a process state diagram where the execution will happen. In this state, the process is running on the CPU. The CPU processes the instructions present in the process. For packing, what has to be done? For bathing, what has to be done? For dressing, what has to be done? That instruction will be processed over there in the running state. And one process is selected from the that is called a short-term schedule. Out of all the processes which are there in the ready state, one process will be selected based on the priority, based on the scheduling algorithms. Each will be taken to the to the CPU to do the processing, and that we call it as a short-term scheduler. Here, the selected process is switched to the running state. From ready state to running state, it will be switched, and that will be done by the dispatcher. So dispatcher means it dispatches the job. He finishes the job, wants to finish the job. He wants to allocate the memory. So he sends to the running state. Next one, we move to the waiting state. As I have told you before, waiting state means I am ready. Everything has been running now. I am running now. But in between, I need some kind of a input I need. There may be some kind of operation I have to do. Okay, for that I need an input from other person. I need a resource I need. So what I will do, that resource is not available means I have to wait. So perform any kind of IO operation, it will be waiting state. If it needs any input from the user, it will be put in the waiting state, because a process will be done not alone, right? If a process has to be done means it require many resources, one or more resources are required to do that process. If any one of the resources is not available means, then automatically it will be put in the waiting state until this resource has been allocated to that process. So in this state, the process remains in the main memory. After completion of the process, again it is switching back to the ready state to do its process. Next we move to the last state, that is terminated state. What is terminated state? The process will be terminated after completion. I just woke up, dressed up, now I had my food, packed my things, everything is been done. Now I reached my office. So then the process is complete. But in case this is after completing its execution, this is normally completing its execution and it's terminating. There can be another reason will be there, forcefully terminated by the operating system. When a process can be forcefully terminated, these are the scenarios. Whenever a segmentation fault has been done. What do you mean by segmentation fault is, whenever I access an illegal memory, that particular process accesses an illegal memory, OS will abruptly terminate the process. Next one is division by zero. Whenever undefined operation is being done also, that process will be terminated abruptly. Whenever out of memory is being taken, that is more memory is being needed for a process also exceeds the memory, then also it will be terminated. Then hardware failure. Whenever the power is being shut down and a hardware problem was there, that process will stops at that time. So these are some possible places where the termination of a process can be done abruptly, and this is called completed state or terminated state. Then next, these are the 5 things that we have come across. Other part is the operation of a process. What is these are some 4 operations are there which will be taken place. Either creation will be done, scheduling will be done, execution will be done, and deletion of killing will be done. So creation of a process, after creation what it will be done, it will be scheduled to do scheduled to a main memory, and after scheduling to main memory what will happen, it has to be executed. So that execution will be done in the CPU, and then last one, deletion or killing will be done. So these are the 4 different operations which will be happened in the process, and these are the 5 different process states that happens in an operating system. I hope these terminologies been clear to you, and you can also recall all these concepts which we have learned over here by asking these questions to you, so that we can have a better understanding. What is a process in an operating system? What does a new state of a process indicate? When does a process enter a ready state? Can a process move directly from a running to ready state? You just have to draw that process state diagram, then you can have a clear understanding. Be clear with all the small concepts, so we can have a better understanding. We can move to the other scheduling algorithms and other types of things that we are going to learn in the operating system. Next, we'll move to the types of schedulers and the queues in the next session. Thank you so much.